In this video, we will be discussing Lewis dot structures and expanding them to look at how we can explain covalent bonding using the Lewis dot system. We will then describe how many electrons are involved in single, double, and triple bonds. Covalent bonding occurs when two or more electrons are shared between two atoms. This is as opposed to ionic bonding, in which an electron is transferred from one atom to another. The electrons that are shared by atoms are called bonding pairs. The electrons that are not shared by atoms but belong to a particular atom are called lone pairs. So looking down below, we can see we have the shared electrons that are going to be written between two atoms. These are the bonding pairs. The lone pairs will be written in such a way that they are not between two atoms. So the way that you would draw out your initial Lewis dot structure is you would start with the Lewis representation for an individual atom, let's say oxygen. Oxygen has 6 lone pair electrons. So we'd start out with our symbol for the element and then put 6 dots to represent these 6 lone pair electrons. That'd be 1, 2, 3, 4, 5, and then to keep consistent with our drawing below, 6 like this. Okay, and then we could also have hydrogen atoms off to the side, which each have 1 electron to them. So the symbol for hydrogen would be like this, because each hydrogen has 1 atom. For oxygen, it is as drawn before with the blue dots. We can then see that the 2 electrons, one coming from a hydrogen, one coming from an oxygen here, are forming a bonding pair. We have another bonding pair located here. What we then see is that the hydrogen atoms have a total of 2 electrons around them each. And the oxygen has 8 total electrons around it. 6 that came with it and 2 additional, 1 from each hydrogen. So in doing this, you have your oxygen, which gets its filled octet. It has 8 electrons around the oxygen. Each hydrogen, which is trying to get a duet, because it only has a 1s orbital, each hydrogen that's trying to get a duet achieves the duet by sharing 1 electron with the oxygen in exchange for the oxygen sharing 1 electron with each one of the hydrogens. When 2 atoms share 1 pair of electrons, the result is called a single covalent bond. That involves the sharing of 2 electrons total, typically 1 coming from each one of the atoms that's forming the bond. One atom may use more than 1 single bond to fill its octet. This typically occurs to different atoms, and it should be noted, as we said before, because the hydrogen only has a 1s orbital, hydrogen can only form a duet. So the oxygen, in an attempt to fill its octet, will be sharing 1 electron with 2 different atoms. By sharing 1 electron with another 2 atoms, it's able to gain an additional 2 electrons around it for a total of 8. So again, the bonding pair of electrons are, for now, going to be represented with the double dots between the 2 atoms, and the lone pair by the set of double dots that is not between 2 atoms. Later on, when we're looking at Lewis dot structures in a future set of videos, we will be changing these to solid lines. Atoms are not limited to sharing a single electron with another atom. In some instances, each one of the bonding pair can share 2 electrons for a total of 4. When 2 atoms share 2 pairs of electrons, the result is called a double bond. 4 electrons are being shared between the 2 atoms. A common example of this is O2, oxygen. Each oxygen brings with it 6 electrons, and by sharing 2 electrons with the other atom, you can get a total of 8 around each one of the 2 oxygens. So these 4 here in the middle 2 come from the left oxygen, 2 come from the right oxygen, giving you a total of 8 electrons that are being associated with each one of our oxygens. So each oxygen atom is able to fill its octet, and it can do that by sharing 2 electrons of its own to receive 2 electrons from the other oxygen. Some other elements that we will work with that can form double bonds with each other and themselves are carbon, nitrogen, oxygen, sulfur, and phosphorus. However, the sharing is not limited to just 2 sets of electrons. We can go as high as 3, at least for this particular class. When 2 atoms share 3 pairs of electrons for a total of 6, the result is called a triple bond. Again, we have 6 electrons being shared between 2 atoms. Typically, this is going to occur when each atom shares 3 electrons from itself with another atom that also shares 3. A prime example of this would be nitrogen, N2. Each nitrogen brings with it 5 valence electrons. It will keep 2 of those valence electrons with itself and then share the other 3. So you have a nitrogen here having 2 of its own electrons being a lone pair, and then it's sharing 3 other electrons, or 3 of its valence electrons, to form a triple bond with the other nitrogen. In doing so, each nitrogen, because it shares 3 and receives 3, is able to get the filled octet. This nitrogen has 2 electrons in a lone pair and then 6 electrons involved in its triple bond. Again, another way that we will be representing this is, instead of having all these dots, is representing bonds with solid lines. Other elements other than nitrogen are able to form triple bonds with themselves and each other. This includes carbon, nitrogen, oxygen, and sulfur.